Alright, next one on our list is number 57. 57 wants to know impulse. Several of you missed this. You shouldn't. Impulse is equal to a change in momentum. MV final minus MV initial. 58 is asking you about rotational kinetic energy equal to 1/2 I W square. 59, index of refraction, N is equal to C over V, and Snell's law is N1 sine theta 1 equals N2 sine theta 2. So there's your equation for index of refraction. There's your Snell's law equation. Two equations for electric fields. E is equal to, and several of you missed this, and this is what you just did. KQ over R square, and E is equal to F over Q. Technically, there's a little circle on that one. (61) Efficiency of an engine and a Carnot engine. Alright, basic efficiency of an engine is equal to work of engine divided by Q from your hot sauce, hot source. Efficiency of a Carnot engine, 1 minus TC over TH. There's your Carnot efficiency. Oh, I got sleepy. 62, a critical angle. This is for internal reflection. Is equal to N2 over, it's either N2 over N1 or N1 over N2. I mean, all I know is when you divide those, it's got to come out to a decimal, so that's how I know how to do that one. N2 over N1, I was right. And like I said, I don't so much even remember the equation, the N2 over N1. It's just that whenever you divide these two, it's got to come out as a decimal. So the N1's got to be greater than the N2. 63. Energy equations. Okay, what the world was I after on this one when this was wrote? Energy equations? Perhaps I wanted E equals HF, maybe E equals MC square. I'm not really sure what I was after. I mean, we've got our kinetic energy, potential energy. Y'all have to remind me what it was we was looking for on 63. 64, pressure equation and the cylinder equation. Pressure is equal to F over A, and the equation for a cylinder is F over A equals F over A, because pressure should be equal, therefore constant in a cylinder. 65, volume of the sphere. Volume is equal to 4/3 pi r cubed. A cylinder, volume is equal to pi r square, area times how long the cylinder is. Circumference and area of a circle. Alright, 66. Circumference is equal to 2 pi r. Area is equal to pi r square. A lot of times we end up using, when we do those cylinder questions, we end up using that tied back in with it. 67. Resistance of a wire. Resistance in a wire is equal to rho L over A. And once again, we'll probably use area mixed back in with that. So, and this little rho is resistivity. Remember, every wire has a different resistivity. The lower the resistivity, the more conductive the wire is. 68, the right-hand rule. There's your velocity. There's your magnetic field. Coming out of your hand is the force. Of course, remember this is for a positive object. 69. Relationship between period and frequency. T is equal to 1 over F. There's your relationship between, they're inverse to each other. Start back up again. 70. Let's say a series. You just did these the other day. A parallel. Oops. That's all you got for a parallel. So once again, there is your parallel. There is your series. 71. Difference in convex and concave lens focal points. Convex has a positive focal length. Concave lenses have a negative focal length. 72. Charge in a capacitor. Q, V, C. 73. Two equations for the potential of charged particles. Let's see. Potential energy can be equal to Q delta V, and potential energy is equal to K Q Q over R. '74. Wow, what did I miss? Oh, two equations for potential. 74. V is equal to negative ed, and V is equal to KQ over just R. I mean, KQ over R square is an E, an electric field. Remember, this one's scalar, so there's no directions on the potential. 74, 75. Frictionless heel, A is equal to G sine theta. 76. Period relationship to big G and centripetal velocity. Not sure what I was wanting you to do here. There's a chance I was wanting you just to do this. Big G M over R square equals MV square over R. And then the M's cancel, that R cancels the square. And here's how period ties back into this. Anytime you've got something moving in a circle and you hear a reference to a period, all I can do, that's the time for it to go around the circle. I'm going to tell you what's going to happen is they want you to do this. Plug V is equal to 2 pi R over time into there. All it is distance over time. Because think, if you're moving in a circle, your circumference. So this ties back into here, which is actually where Kepler's law comes from. That T square equals 4 pi square over GM R cubed. All it is this plugged in and the equation set up. That's it. That's where Kepler's law comes from. But really what I was wanting you to remember was this. There, sorry. 76. Anytime you're given something moving in a circle, whatever, just remember you can always plug 2 pi R over time, or period, back into the equation. 77. Equation for G on a planet. mg is equal to big G M over R square. Your m's cancel. So gravity on any planet can be found as long as you know big G, which is a constant. You know the mass of the planet and how far you are from the center of the planet. 78. An explosion. 0 equals M1 V1 final plus M2 V2 final. 79. C for water. 1 cal per gram Celsius degree, or 4,186 joules per kilogram Celsius degree. Number 80. VOY is equal to VO sine theta. VOX is equal to VO cosine of theta. Finally getting close to the end of these. 81. Let's see, specific gravity is something's density and something's density compared to water. So remember, the density of water is 1 gram per centimeter cubed. So the specific gravity of water is 1. So if something were to have a specific gravity of 13, that means its density is 13 grams per centimeters cubed, or 13,000 kilograms meters cubed. That's all specific gravity means. It's something's density compared to water. 82. Difference between alpha and beta decay. Beta decay is where you take your initial nucleus and you lose 4/2 He. So in alpha decay, if you started with like a 23892 piece of uranium, you're going to be left with a 23490 piece of thorium and that 4/2 particle. Beta decay, I'm trying to think of a type of beta decay, and I need a periodic table to like write an actual example, but carbon 14, beta, negative beta decay, nothing but an electron. Carbon 14 undergoes beta decay. All you got to remember is when you have negative beta decay, the atomic number goes up. It's kind of like a little inverse thing, which means on the other side you get 14/7 nitrogen plus your beta particle on the other side. And technically a neutrino on the other side. But anyway, all it is if you get positive beta decay, all that happens on the other side, whatever element you got, let's say it was 120/78 something another. All that would happen is in positive beta decay, 20/77. You lower that atomic number. That's it. '83. Work net is equal to 1/2 mv squared minus 1/2 mvo squared. '84. Sorry, I'll be right back.